Welcome to the May edition of Vancouver's OWASP chapter. Tonight we have two special guests, Jeff Williams and Bipin, who are going to speak about instrumentation use in automating AppSec and security microservices respectively. Our first guest, Jeff Williams, he brings more than 20 years of security leadership experience as a co-founder and chief security officer of Contrast Security. He recently co-authored the DZone DevSecOps, IAST, and RASP refcards, and speaks frequently at conferences including JavaOne, Java Rockstar, BlackHat, QCon, RSA, OWASP, Velocity, and PivotalOne. He's also a founder and major contributor to OWASP, where he served as global chairman for 9 years and created OWASP Top 10, OWASPEnterprise Security API, OWASP ASVS, which I use almost daily. So thank you for that, Jeff, and all the other stuff. XSS Prevention Cheat Sheet, and many more popular open source projects. Jeff has a BA from Virginia, an MA from George Mason, and a JD from Georgetown. And he's a bit of a celebrity in the OWASP circles. We're very excited to have him here tonight. And without further ado, I'll pass it to you, Jeff. Oh, you're on mute, by the way.
Thank you very much for the nice introduction. It's kind of ridiculous to be called a celebrity in AppSec. There's like, a few hundred people in it. It's amazing, actually, that after 20 years that people are still using my stuff. Like, I wrote WebGoat in like 1999. It's ridiculous. I mean, and actually it's a condemnation of what we've done as a community. I'm proud of the things that we did at OWASP and, all the progress we've made over the years, but frankly, we're losing this war. There's way more software now, and the software is being built faster, more complicated, more risks, more critical purposes, more interconnections, more complexity, and AppSec is creeping along. Maybe we're making incremental progress on the margins, but we are not winning this war. We've got to do a lot more if we want to, make the internet safe for my kids and your kids and all the important things that we do using computers these days. So today I'm really excited to talk to you about security instrumentation. I think it's one of the most powerful AppSec technologies that exists. It's really interesting and exciting, and we're kind of at the beginning of it. So, it's a great time to get involved with instrumentation and learn about the power of what you can do with instrumentation. I just finished the book called The Codebreaker. It's about gene editing and CRISPR and it's actually, a lot of ways, it's very similar to what you can do with instrumentation. So I'm excited about the future of both fields, but I'm going to try and introduce you to instrumentation. I'm going to assume that you guys don't know anything about it, and we'll start from the beginning, but we're going to go pretty fast and do some more advanced stuff towards the end. So please interrupt me with questions. I'll try to keep up with the chat if you ask questions there, but don't hesitate to stop me and ask me questions about anything. And I want to thank you all, just right at the outset, I want to thank you all for being part of OWASP. We are, in the words of Josh Corman, we are the cavalry. So if anything's going to get better, it's going to be because of you that care enough to come to a meeting for me, it's like the middle of the night on the East Coast. So I appreciate you coming out. All right, let's jump into it. So I'm going to share my screen here. Okay, hopefully you can see my screen. And into this here. So I wanted to start with a couple of plugs for my own articles, which is shameless, but I spent 20 years doing AppSec and I learned a lot along the way. I made a ton of mistakes. And so I wrote a couple articles capturing some of the key lessons for people starting out in the field. The first one, I called it How to Vulnerability. And it's about how you write up vulnerabilities to communicate them to people effectively. And I'm sorry, I worked with lots of consultants and I trained lots of consultants how to write about security and write about AppSec vulnerabilities. And I'd be willing to bet that you're doing it wrong. If you're a pen tester or a code reviewer or you triage stuff and you write up findings, you're probably doing it wrong. So I wrote this article. I encourage you to read it. There really is a compassionate, complete, and compelling way to explain security issues without pissing people off and without undermining your application security program. And so this is a very how-to article. It's a recipe for how to do it right. And I strongly encourage you to make this perfect. It'll make you a 10x better application security person, because any idiot can find a vulnerability, but if you can't communicate it to the people that need to know it in a compelling way that makes them take action, you've accomplished nothing. So I'll just throw that out there. Please take a look if that's part of your job. The second article is a little more fundamental. This is a broader view of kind of how we do application security today and why it doesn't really work as part of a modern software factory. And I use that term software factory. It's a little outdated, but I use it because I want to convey the whole software development organization, all the pipelines, all the projects, the people, even operation, all fall inside that organization. And I want you to think about, how do you improve the security that's produced by an entire software factory? So there's some challenging ideas in there. I strongly suspect you'll disagree with a lot of them. I would love it if you argued with me on LinkedIn about it, because again, I'm focused on trying to make the future of AppSec better than it is today. Okay, so brief detour there. I hope you check those out and give me some feedback. I'm going to start this talk by talking about how we communicate application security today. And I'd be willing to bet that you've seen PDF reports full of vulnerabilities, dashboards, Jira tickets. You might fail a Jenkins build. You might get an IDE plugin. You might get it via Slack. You might get findings via some kind of REST API in a custom dashboard. But all of these are really weak ways of communicating. You really have to get vulnerabilities to the people that need them through the tools they're already using. Otherwise, you'll just irritate people or get ignored. And it's not enough to just find vulnerabilities and throw them over the fence to the development team. Like, our job as AppSec people is to ensure that the software we're producing is trustworthy. And so I encourage you to think about how the way you provide feedback can lead to long feedback loops that lead to massive backlogs of vulnerabilities. And we just did a survey. It's literally absurd, the amount of vulnerabilities that are stored in big companies' backlogs. It could be 20,000, 50,000 vulnerabilities just sitting there in Kenna or Defect Dojo or some thread fix or something. But we're not effectively communicating security to the people that need it in a way that gets them to fix it. That's on us. So again, I encourage you to read the article and then think about, what kind of communications infrastructure do you really want? I really believe that the right approach to application security is real-time notifications. So as soon as you write some code, maybe you run some code, you run quality tests, you need to be generating real-time alerts that notify people, right in the tools they're using. If they're a security person, maybe it's right in their testing tool. If it's a developer, it's right in their IDE. Let's get an alert that tells them, hey, you just introduced a SQL injection, and shows them what they need to do to fix it. So hopefully this is the death knell for PDF reports, but I seriously doubt it. Okay, so I want you to think about observability. Now, in normal development, there's lots of effort towards making things observable. Observability is about exposing the internal workings of something so that you can see what's going on inside and make smart decisions. And lots of things are observable. There's a lot that's observable about your car's engine, in the real world, like complex things. We have pretty good observability. You wouldn't think about driving your car or flying your plane without any gauges and dials and alerts and sensors and things. But we don't have good security observability for applications. In fact, software is probably the most complex thing that man has ever built. And yet we have very little insight into what's going on inside them. You could be completely getting hacked through an application and not even know it, because it wouldn't show up in log files. It wouldn't show up in your dashboards. It's just invisible that you're getting completely pwned under the hood. So I want you to think about, what would you expose? What going on inside your application would you like to be able to monitor? Would you like to be able to see anomalies in? That's the question that we're going to be asking today is, how do we get this feedback? How can we create these really tight feedback loops? And how can we prevent our applications from going off the rails? Instrumentation is the key to creating observability, and instrumentation is amazing. This is the 9450. It's an instrumented basketball, and it's really cool. It's got some sensors inside it that measure dribble speed and rotation. It can even tell if you made or missed a shot, and it can measure the arc of your shot. And so it collects all this data, sends it to an app on your phone, and gives you really smart tips about improving your game. I was shooting too flat before I got this thing, and I got it and improved my shooting dramatically just by working on my arc. And I want you to think about, when you have instrumented basketballs, the role between player and coach changes. You can tell your players, hey, go work with the ball. I will monitor your results and make sure if you're struggling, I'll come and help you and give you coaching. The players that get it can make progress at their own pace. The players that need help can get attention from the coach, but it's a force multiplier for the coach. And if you think about it, this is really one of our big problems in application security. We don't have enough coaches. We've got lots and lots of developers spewing out tons of code. I think there's, almost 30 million developers in the world putting out code really fast. There are not nearly enough serious application security experts to secure the amount of code that we're producing. So we need those force multipliers. And instrumentation can help. It changes the calculus between doctors and patients, programmers and security experts, players and coaches, and so on. It can really change the scalability. The good news is instrumentation has been around for like 20 years. It's for software. It's really powerful, and it's actually pretty easy. Now, here's how it works. And every language is a little bit different. This is modeled on the Java Instrumentation API, but there's a profiler API in .NET. There's instrumentation interfaces in other languages and platforms, but they all mostly work like this. The first thing you do is you add an agent, and it's got some sort of transformer in it that will modify code as it loads. So you start with your original code on disk, and normally this code would load right into memory and start executing the exact way it was on disk. But if you instrument it, you're actually changing that code on the way into the application. So then the instrumented code is what's in memory. It's slightly different than what's on disk. And you run that instrumented code. And actually, you could have produced the exact same instrumented, the exact same code as though it was instrumented by changing the source code and just compiling the instrumentation into the application. But doing it at runtime is really powerful. It allows you to change the instrumentation without having to go back to the source code and change source code and recompile and redeploy and redeliver. You can change the instrumentation very quickly, as we'll see in a few minutes, and just modify the code and put different sensors in and make sure they're working. So it allows you to experiment much faster. So today I'm going to show you a number of things that you can do with instrumentation. And again, this is proven technology. It's actually already used in probably most of your applications. It's part of Spring Framework. It's used in APM tools like AppDynamics and New Relic. This is exactly the same thing, but now we're using it for security. So we can get, you'll still see some of the advantages of using instrumentation in a minute. So the idea here is we're going to use instrumentation. I think of it like having a buddy inside the running application that can tell me what's going on. Whatever I ask him to tell me, he'll feed me that information in real time. So instead of, if you imagine this like a normal pen test, you're over here on the left just sending attacks, and you have no idea what happens inside the application, except you get an HTTP response back that has a 500 error in it. Well, I don't know what happened inside there. Did we hit a SQL query? What caused it to fail? We don't know. But with instrumentation, we can make all of that stuff observable. And the reason for doing this is that really it's very difficult to tell how an application is actually going to behave by looking at the source code or by testing it from the outside. You just don't, like with source code, you just don't know how all those pieces are going to fit together and how they're actually going to work at runtime. Remember, in a modern application, you're loading a ton of libraries from the production environment. They're not in the source code repo. They're not listed in the POM or anything. They're loaded at runtime. You could get a completely different XML parser at runtime. A lot of the libraries come from the JVM that you're using and the app server that you're using, like maybe it's Tomcat or Glassfish. So all these things are different at runtime, and they can dramatically affect security. So really, for me, the right thing to test is the fully assembled application with all the plugins loaded and dynamic libraries loaded, all the code loaded. That's the thing you should analyze for security. If you're analyzing source code, you're looking at a weird view. If you're only looking at the HTTP view, it's very difficult to understand what's going on inside. So we're going to get inside the black box and see what's going on. There's a question here that says, can instrumentation be used with serverless? And the answer is yes. Depends a little bit on the serverless environment that you're using, but some people use Java for serverless, and you can use exactly the techniques I'm going to talk about tonight for that. But we have, in our commercial product, we have support for Java, .NET, .NET Core, Node, Ruby, Python, and Go. So, depending on the environment, you can add instrumentation to it for security. Okay, so let's get started a little bit. I'm going to introduce you to instrumentation using a toolkit I wrote called JOT, the Java Observability Toolkit. And essentially, I just wrote a layer on top of the Java Instrumentation API and made it a lot easier so that, without a ton of programming expertise, you can create your own sensors, you can add them to applications, and you can make just about anything you want inside those applications observable. So, you can find the open source project here. It's easy to make really cool sensors using JOT. So I'll give you some examples of that tonight. And we'll look at some good security uses for these things. Okay, so let's start with a ridiculously simple example. I want to understand if my application is using weak SQL queries, like unparameterized queries. So I'm going to create a JOT. That's a YAML file that looks like this. What this does is it says, hey, I want to put a sensor on unsafe queries. So I'm going to specify these 4 methods as the methods in Java that send unsafe queries to the database. I'm going to exclude prepared statement because it actually extends statement. And so, I automatically would have identified it. So we're going to exclude it. And what we're going to capture are the arguments to these methods. The arguments are the query. So if you call statement.execute, the arguments there's only one argument, and it's the query. So that's what I want to capture. So I'm putting a sensor into these methods. I'm saying, if these methods gets called, capture the query and tell me, the details. So let's take a look at that. So here's what we do to run that. I've got my environment here, and the normal way you'd run this application is just start up Tomcat. I'm going to set an environment variable first that tells Java to use the JOT library, which you can just grab the latest version off of GitHub. And I'm going to tell JOT to use this little JOT file, which is the one I just showed you. And that's it. By setting that Java tool options flag, now anytime I run Java, it's going to use that Java agent. So when I start up, you can actually see at the top here, these methods are telling me, hey, I instrumented those methods and the toolkit was installed, and this takes literally no time to start up. So you're not talking about a performance impact for this kind of instrumentation. So then I can just use this application normally. So I'll register here, I'll put in Jeff and some city and a credit card number and register. And maybe I'll hit the list here. I might check one. I might put in and just look up somebody. And what you can see here is the instrumentation is, make it still small so you can see it. The instrumentation is capturing a table full of all those queries. So I can see, hey, look, this first one in a method called update unsafe in the database class called drop table tickets. And this is sort of the first thing it does is drop tables, then it creates a new table of tickets, it fills them all, then this is the startup. And then you can see later on, here's where I did a select for 1002. So this is actually pretty cool. I know the exact line where this query goes. I can even get the full stack trace to see who called the database class. I know it happens to be in check.jsp because that's how this thing works. But I can track this down, and I know this is an unparameterized query. So if you know anything about AppSec, you're probably thinking like, wow, that's probably SQL injection. And sure enough, if you want to inject into this, it's a valid SQL injection. So that's a really simple example. Any questions on any of this? Oh, there's some good questions in here. So let's see. I haven't messed around with Microsoft App Insights, so that's interesting. I'll have to check out what they're doing. You don't have to create a baseline. You could use instrumentation to create a baseline and then look for anomalies relative to that baseline. But here I'm looking for things that are like literally known bad patterns of application security. And I'll tell you, you can any pattern of code execution that you want to put sensors in and monitor, you can do it. So I'll show you some more examples, but you'll get a sense of the power of this very quickly here if you want to look for interesting things.
Jeff, quick question.
Yeah.
Can you anonymize the data that gets returned out of there? So if you had sensitive information that you don't want to get into your telemetry data, they don't show up. Like let's say you had some passwords or some other things that were coming back or keys. Is there some way to be able to see the patterns without seeing the data?
You can do that. We do that in our commercial product, but Jot doesn't have any capability like that. You'd probably want to put some post-processing. I mean, Jot's intended for security researchers to use in a local environment where they're not going to be exposing the data. But you could add. I mean, look, with instrumentation, you can do whatever you want. You want to filter the data, you can do it.
Yeah, just thinking about ways to mask out things like credit cards or passwords or things that you don't want to expose, but you still want to see what was the format of the query or what was going on, et cetera, et cetera. Yeah.
I mean, look, a pen tester is you don't really have to mask your data from the pen tester, right? Like there's a lot of uses for instrumentation where you wouldn't want to create, observability into all the tokens and passwords and so on. So yeah, you want to be careful if your sensor, and actually that, if you want to contribute to Jot, that would be a great extension is we could add something to the language that says mask this field.
Yeah, or even just that pattern. So you could have regex pattern that says if you see these type of things and this kind of thing, mask it out. That's what App Insights does now, is that you can actually have columns or whatnot in databases and say anytime this is instrumented out, mask that field. And then that helps to hide things that, especially if you're going to allow this telemetry data to get back to developers, if it's in an environment where you don't want them to see the data, but they need to see the queries and everything else as it's going through.
Yep. That's a good idea.
Thank you.
Somebody submit a ticket for that to Jot and I'll do it. There's a question about, can this be injected into a CI/CD pipeline like Jenkins? And absolutely, anywhere the code runs, you can use instrumentation. So developers can use this locally in their test environment that they're doing, local. You can put it in a CI/CD environment and run automated tests as part of your build process. You can put it in a test environment, so it's in the background while you're doing QA, and you can do it in production. Testing in production is not a ridiculous idea. And this is a really powerful way to do it and it's all passive. So you're not going to affect the operation of the application, which is cool. Let's look at some more examples. I want you to understand the power of what we can do with instrumentation here. So that was a very simple example. Here's another example that says, hey, I want to understand what encryption is going on in the application. So that's an interesting question. A lot of encryption happens really deep in libraries. And so, with instrumentation, you could find it in a way that you could never do with static analysis or source code reviewing or whatever. So I'm going to change my jot file to something called ciphers.jot, which is what we just looked at. Here, I'll show it again. Here it's in directory. So here you can see this really simple jot. It puts one sensor in cipher.get instance and captures the first parameter, which is the name of the algorithm. And then it just creates a list, and it's going to dump out the ciphers and like where they're used in the code. So I set my environment variable, run the application normal way, and that's up and running. And so now when I use this application, I'm just going to click around on some fields here and like on some menu items and just browse around a little bit, because I just want to hit some of the methods that that might do encryption. So I'm just clicking on some pages here. I'm not doing any kind of security testing, but in just that amount of time, I was able to generate a nice table that says, hey, here's all the places in this application where encryption gets used. And you can see there's a method called ticket.encrypt. There's also some JSPs that are doing their own encryption. And in fact, if you look at this list, you can see access A is written there twice and access E is written there twice. Access E does both triple DES and AES, which is nuts. So this is like, again, observability will make things pop out that would have been really difficult to figure out manually or any other way, actually. So, I'm just thinking back to when I was doing a lot of pen testing, is I would have given my left hand in order to have this kind of information feeding back to me while I pen test. It's so powerful. Even things that aren't like directly related to vulnerabilities, like I could create a jot here that just told me all the parameters that were actually used in each route. I've got a jot in the jot project. There's one that does that. And that's super powerful. Like, you could see secret parameters that aren't exposed via the HTML anywhere. You would know that they're there, and you could test them as part of your security testing. Great question about, can alerts be part of jot for users to be informed? And right now, jot doesn't have anything like that. It's really focused on just, sort of a console kind of output. I just haven't had time to build it. It would be really cool to be able to do more with this output and build the kind of alerts that I think people want. Okay, so that's just a simple example with encryption, just to give you another sense of the power of this. I want to show you one more example about access control. So I'm going to show this to you live in the window here. So I'm going to start with the jot file. This jot does a couple of cool things. It has several different sensors. The first one captures the route. Every application has a bunch of routes. A route is just a mapping between the URL and the code that runs to process that functionality. So in Java, we can capture that. We put a sensor inside the service method. I don't know what I just did. We can put a method inside the service method here. We're going to capture, and this capture is actually a Spring expression. So we're going to capture the first parameter to the service method, which is the HTTP request. And then we're going to call the get remote user on the HTTP request. So this is going to get me the user. I'm sorry, the first sensor gets the route. That's the same thing, but we're going to get the URI off of the HTTP request. The second one gets the user. And if it's nothing, then we're going to use guest. And then the last one gets the role. Anytime the isUserEnroll method gets called, that's an access control check. We're going to capture the first parameter, which is the role that's being tested to see if the current user is in that role. We're going to dump this out as a matrix. And so you can specify the output here, both a test coverage matrix and an access control matrix. So this all, that's it. This is incredibly powerful. I don't know if any of you have done any, application security testing, but access control is one of the hardest things to do. It was kind of one of my specialties. Because it's really hard, you have to kind of reverse engineer the access control matrix and then try to test against it. That's really hard. But with instrumentation, I'm going to specify to use that JOT file, and then we're just going to run the application the normal way. Here we go. And we've put a few more sensors in there. Application starts up. And now I'm just going to click on these access examples because I think they're pretty powerful. We can just click on these 5 URLs here. And what this shows us is, I guess I didn't click on all of them. Let me try again here. You got to make sure all of them actually run. You can see here in just that little, just clicking on a few things, you can see the test coverage matrix says, as guest, I access these 5 pages. Okay, that's useful. If I'm a pen tester, that's really useful. But this access control matrix is absolutely gold. This says page A checks for role A, page B checks for role B, page C checks for role C. Wait a minute, where's page D? Page D doesn't have any access control checks in it. That's weird. And then page E has 3 access control checks in it for role A, role D, and role E. So that's weird. Now, none of this is necessarily an error, but we've made access control observable. The people that wrote this application it would be very easy for them to just kind of look at this and say, oh, wait a minute, why does role E, which might be called admin or guest or manager, why does role E have access to this page E? That shouldn't be. So it's a very quick way of testing access control in a way that would be, it takes weeks to do this manually. So we can click on the rest of this, get some more data in. I'm just clicking through these pages really quick. You can see as we go, we're continuing to build out our test matrix, and there are no more access control checks in these pages. These access pages actually have this feature where we can switch users quickly. Normally you'd have to log out and log back in, but I just made a shortcut here. So if I click on each of these and click on access A, like page A here, you'll see what happens to our access control matrix. Now I've got, our test coverage matrix. So you can see now I've tested all these pages as guest, and access A, I've tested with all these different roles. So I can go through the various roles, like if I go to B and test page E, C and test page E, I can fill out some of this grid, but so here you can see now I've tested a little bit more of this this framework. But if you look at the access control matrix, you can see, hey, wait a minute, page B has a test for role B, so I should probably test page B with role B, and you can see there's a big gap in my test matrix right here. So again, this is almost impossible to do without a tool like this. So I strongly encourage you to test access control. It's a ton of fun, and you can use this this JOT framework to get really cool insight into it. Any questions on access control there? Okay, let's take another. So we're not quite done. There's a couple other things you can do with JOT. One thing you can do, and I've just started experimenting with this, is you can use JOT to create these security flow charts through an application. So what I'd show here is a SQL injection example. You can see what I did is I put sensors on the route, any calls to get parameter. It'll show me the parameter name and the value of that parameter. SQL queries, I also put sensors on encryption and expression language evaluation. So this is kind of cool. You can see, hey, we can just look at this flow and see, hey, I got this parameter right here. And then the very next step is I use that parameter in an unsafe query. Wow, that's kind of cool. If I'm a pen tester, now I can kind of put the whole thing together and I can see like, wow, that's an interesting flow through the application. And I don't have to go hunting all over the place to try to find paths that might have SQL injection on it. Here's another example of expression language injection. You can see here, this route, it's actually called el.jsp, which is a bit of a tip off, but it sets some headers. It calls an expression language evaluation here, and you can see the expression that got evaluated 8 times 8. And then you can see here's another one. So that's kind of hard coded, but you can see this one calls get parameter. And you can see the parameter here is midwinter. And you can see that the expression evaluated midwinter. So if I'm a tester, I'm thinking, wow, I should put a malicious expression in this parameter and the input parameter and see if I can get it to actually run. Expression language injection is all over the place in Spring and Struts apps, and I guarantee there's other ones out there to find. Last one is command injection example. This is a little more complicated just to show the power of this, but you can see here, get parameter, that gets passed to runtime.exec. But you can see there's a bunch of stuff. Actually, this all happens inside runtime.exec. There's encryption inside there where it runs through a bunch of algorithms and actually connects to a socket. So there's a bunch of things that I wouldn't have expected inside this simple command.jsp. It's actually doing a ton of work that I had no idea about. Again, it's all invisible. If you're looking at source code, you got to look at the running app if you want to figure this stuff out. It's just way too hard trying to do it the source code way, whether you're using static tools or just doing it manually. Good questions here. Let's see. Thoughts on doing this in a more generic way than just Java? I think it's probably got to be language specific. Every language has its own constructs that you'd want to instrument and its own techniques for instrumentation. So probably separate, but you can do this in other languages. We do it in our product. We do it for, again, Node, in Java, .NET Core, Node, Ruby, Python, and Go. There's a question about C and C++ and Go, and actually you're right. We had to invent a new technique for instrumenting in Go, and basically we instrument during the compile phase with Go. So we add our changes in at the compile stage, and then it runs with instrumentation. You can do the same thing for C and C++. And it's not really about compiled versus interpreted. There's instrumentation, there's even native instrumentation for C and C++ apps. Good question on deserialization. Great example. You can absolutely put sensors into the deserialization methods like read object and write object. And you can put them into the libraries that do deserialization, and things like I'm blanking on the libraries, Jackson and so on. So yeah, great way to get insight into what's going on here. So you remember I started this out with communication with developers, and I think there's a really cool way to use instrumentation to communicate security via test failures. I wrote an article about it, so I'll plug that. Here's the bottom. But imagine if you're a developer, you're coding along and you write some code that happens, maybe it happens in a library that you invoke or somewhere you can't even see, but it invokes runtime.exec. And you want, and like maybe it's your policy in your organization that that's banned. So what if you could report that to the developer as a failed test case automatically? How powerful would that be? And give them advice on what to fix. So here you can see we did exactly that. All we had to do was add this scope to the test. What this says is the scope says only fire this sensor if you're inside the scope listed in this method. So if you're inside this JUnit method, then we know you're in a test case. And if you call runtime.exec or Java Lang process builder to this thing underneath it, then you'll fail the test case. So here it just works perfectly this way. You just run the tests normally, you fail, you give them great advice. Hey, to prevent command injection, you got to use find a safer way to do that. And you can get a contact information for help. And it tells you exactly where you made that call. So again, it's all about communicating effectively. And this is my last example, but I've really just scratched the surface of what you can do with instrumentation. This is about, what if I actually wanted to use instrumentation at runtime in production to prevent vulnerabilities from being exploited? That would be pretty cool. We could actually eliminate whole classes of vulnerabilities this way. That's how we made progress against kernel exploits in the early 2000s. We invented technologies like ASLR and DEP that made those vulnerabilities incredibly difficult to exploit. We can do the same thing for all the classes of, not just for buffer overflows. We can do this for all kinds of vulnerabilities in the AppSec realm. Someone asks, would that sort of incident, bad function use, or maybe you're talking about the last example I gave with command execution, be better monitored in SAST or DAST? And sure, you could use SAST or DAST for that, but like I mentioned, not all the code is present in the SAST tool might not have access to that. Like you might just make some library call, and deep under that library call might be the call to runtime.exec, which you don't even know is there. And so SAST tools are going to miss that. They don't evaluate the whole application. They just analyze your custom code. So I actually think it's potentially much more effective to give developers feedback this way. And by the way, you said that stuff shouldn't even be checked into the code base. Well, if the developer is using this instrumentation locally, then they get feedback. Like this is just when they run their local tests in their local development environment. No code's been checked in. They're still just experimenting and building stuff. And we're giving them instant feedback right in the IDE. Their test case failed. So it's right part of their IDE. They're going to click on that test case. They're going to go right to the line of code and they're going to go, oh shit, I didn't know that ran command injection under the hood. I better fix that. So let's do this example, this expression language injection example. This is so badass, I can't believe it. First of all, what we're going to do is we're going to go to this expression language example, and we're just going to see, like, look, normal expressions, this just passes them through. And a lot of applications do this stuff. You wouldn't even know that there's an expression involved here. You type in some data and it just, it gets reflected back. It looks like reflected XSS actually, but it's actually getting evaluated. If you put in this special syntax, and I just put like 1+1 in here, we'll evaluate that. See, we're running that expression and it comes back 2. So you can use either $ brace or hashtag brace. Works the same way for expressions. I'm going to answer Will's question in just a second. That's a really good one. So we're actually running some code underneath here, and that's really dangerous. You can put in an expression that looks something like this: runtime.getRuntime.exec, and we'll put in a command here. We'll put in like open-a calculator. I think I got that syntax right. I'm going to copy this, so we'll keep a copy around. And when I submit this, check it out. That's a super simple expression language attack. This is the kind of thing that got Equifax in trouble. It's really powerful to do expression language injection attacks. And there's tons of them because people don't know that, they don't test every field to see whether it's an expression. So now let's try this same example using our a jot. So I'm going to cat jots/eli.jot. And here's the jot I want to use. This is going to, basically, it's really just this. This captures two methods, process builder and socket. And it says, hey, I don't want these calls, and you could make a longer list here, but I don't want these calls to happen anytime we're evaluating an expression. Because if they do, that's an opportunity for the attacker to take over. So we put a scope on this and we say, inside this scope, we don't want these two methods to fire ever. And if they do, we're going to throw this exception. So again, this is a really powerful way to stuff a sensor anywhere you want in an application. You can make any kind of test you want here. There's actually some syntax around, doing some logic here. And then you can fire this sensor and prevent that code from running. So when we run this, I'm going to set, first step is always turn on the jot. Then we're going to run the application normally. Starts up, and now we're protected. So I'm going to run this exact same input. Actually, let's do this first. Let's just put in some safe data. We can even put in an expression that evaluates, because again, we're not running, runtime.exec or anything. So this expression runs, but if we try to run an unsafe expression like we did before, jot intervenes and says, hey, you got an expression language attack detected. It was blocked by jot. That's pretty cool stuff. We just hardened our application against a class of attacks. We did it really accurately. This doesn't false alarm all the time. There's almost no performance impact. And we're a lot safer now. If Equifax had this, they'd be safe today. They wouldn't have gotten breached. And again, these things are really pretty simple to implement. So I encourage you to, dig in and experiment about this. Let me try answer some of these questions going back a little bit here. So somebody said data flow analysis. You can do data flow analysis with instrumentation, but it's hard. That's one of the things that we implemented in our commercial product, Contrast. And it's by far the most accurate data flow analysis anywhere. It's way more accurate than static because we're actually tracing the actual data as it flows through the application. And so you can see the whole path from source to sink with the real data. So we know that data can follow that path, and we can see whether the right defenses are on that path, and we can decide, is it a real vulnerability or not? That's why, that technique is called IAST. We'll talk about that in a second, but that's why it's so much more accurate than static and dynamic. Let's see, what would your scan time if you had to analyze every application and every library in the application? You can't use static on the whole application with all the libraries and everything. It just would take way too long. Let's see. Let me move on because there's I'm running out of time here. So anyway, that was jot. So the techniques that I just showed you have names. IAST is using instrumentation to detect vulnerabilities. That's all it is. I taught you about instrumentation. If you use it to detect vulnerabilities, that's IAST. And I've spent the last 6 years building a world-class product that has all these different sensors built in to find all kinds of vulnerabilities super accurately. And it works exactly the way I just showed you. You add an agent and you use your application normally. You don't have to hack it. You don't have to attack it. It just finds vulnerabilities passively and shows you exactly where they are with the full context. And then RASP, or runtime application self-protection, is just using instrumentation to detect attacks and prevent exploits. You can use that in production. And it's exactly what I just showed you with expression language injection. Another part of our commercial product is RASP. We have agents for all the different language frameworks and environments, and we can give you an insane level of insight into attacks, much more accurate than what you can do at the perimeter with a WAF. A WAF can only see HTTP traffic. It can't see anything about how that data is used by the application or backend connections or anything. And so RASP is just much more accurate than WAFs and a lot faster because, for the reasons we've looked at, it compiles right into the application. No extra hop. So that's IAST and RASP. And IAST and RASP have become part of the major AppSec standards. They're in NIST 853. They're in the PCI standard, the software security standard. And I'm just going to reemphasize, there's a question, can you speak a bit as to how much effort it is to add the instrumentation up front? Is it just a library include, or does there have to be an active developer help to get it working? No, it's literally what I just showed you. Like our commercial product, when we install contrast into something, I think I have an example here. This is the exact syntax I use to add contrast to an application, in this case, Spring Pet Clinic. I just do that, and then I run the application literally exactly normally, just like this. And then, the application runs. I just use the application normally, and I detect all kinds of vulnerabilities. When I do that, just using IAST for a few minutes, this is our contrast product. I'll drive directly to the Spring Pet Clinic dashboard here. In a few minutes, I can get a dashboard that looks like this, that shows me all the libraries, all the vulnerabilities. I can drill into the vulnerabilities and see all the details. And I'll show you this Hibernate injection just because someone asked about taint tracking. You can see here, we trace this, the input data from the HTTP request into the exact method, the exact line of code, right into the query. And you can see that's, that this data was never escaped or parameterized in a way that would have stopped Hibernate injection. And you can get all the details if you pull up. You can see, sort of every place we track this data through the application. That's commercial IAST. Jot is just it's a toolkit to let you build your own IAST if you want to. So IAST and RASP are the technologies, the big class here. And here's and I'm going to wrap up with these quick thoughts on why this is so important. What we've seen is that observability and real-time notifications with accurate findings can make all the difference to your AppSec program. If you see here on this chart, this red line is a major static analysis vendor. They get to median remediation, that's their mean time to remediate, in 121 days. So they fix half the vulnerabilities in 121 days, 71% by the end of the year. And what we've done with IAST, an instrumentation-based approach, is dramatically different. On average, IAST customer gets to the median in 7 days and fixes 61% after 30 days and 90% after a year. So this is a much better curve. And our folks that have been using IAST for a while, their median is 1 day. 75% of vulnerabilities are closed within 8 days. They don't build up backlogs. They're fixing these vulnerabilities right away. This is the measure of whether you're shifting left. This is how you measure it. You measure MTTR, because if you're fixing in development, you're going to be fixing vulnerabilities quickly. And so, this is the kind of thing that IAST can lead to, a much healthier AppSec program. Ultimately, all we want to do is give these tight feedback loops, which is kind of one of the core principles of DevSecOps, tight feedback loops that allow development teams to go fast, push code into production with confidence that they've tested for security. And really, that's how you bring development and security together. Right now, most organizations I've worked at, development, they don't want to get a bunch of false positives. Security doesn't want to triage the false positives, so they throw the work back and forth, and nobody does it, and it just piles up, and you get these huge backlogs, which kill everything. So let's see, a couple quick questions here. CPU overhead of RASP is a few percent, and a little bit of memory use. Could it be done as a step in the CI/CD pipeline? Absolutely. It's a great place to run IAST, is to add it to your CI/CD pipeline. Put it in the background while you run your normal automated tests, and you can even fail the build if there's a new vulnerability that gets introduced. Let's see. Yeah, as long as your team has halfway sane testing, you're right. It's way more accurate than DAST. I'd love to talk to you about how we measure route coverage and how we encourage teams to do better QA so that they get better security. And it's double benefit, right? They actually get better quality testing because they hit all the routes, and they get better security. False positive ratio of IAST and RASP. I can show you the OWASP benchmark is probably the best way to measure that. This is the OWASP benchmark. If you haven't seen this project, these guys created, I don't know, almost 3,000 test cases. Half are false positives, half are true positives. And you run whatever tool you want, you run it against this, and it'll test, it'll parse the output from your tool and then create this graph for you so that you can see it. In this case, you can see most of the static tools are up here. Contrast is way up here at 100%. But what's really important is when you drill into these, if you look at like, I don't know, I hate picking on anybody here. I'll just throw up check marks, for instance. You can see, they're really, static tools are really good at things like insecure cookies and weak encryption algorithms and weak random numbers, because those are right in the code. But as you get closer and closer to data flow problems like FA and E here, or like SQL injection, path traversal, command injection, those are really tough for static tools. You can see they're got a 60% false alarm rate. So it's actually really, this is the only way you're going to know what your tool is good at and what it's bad at. I encourage you to dig into the OWASP benchmark a little bit. And of course, you can see here, the contrast results are really, really good. Question here on, what do you mean when you say it can be added to CI/CD? Isn't IAST and RASP done during live instrumentation? Yeah, so usually in your CI/CD pipeline, you build the application and then you run your automated tests on that application as it's running. And so you add the agent to that phase. When the application runs, you run it with instrumentation, and then all your QA tests run and drive coverage over the application, and you get great security testing results. So look, with that, I'll stop. I really appreciate all the great questions. That was unbelievable. I really appreciate it. And I don't want to interfere with the next speaker though. So if you want, please reach out to me on LinkedIn. I'd love to take your questions about anything related to AppSec. And if you want to check out Contrast, you can reach out to me and I'd be happy to set that up too. Thanks, everybody.
Excellent. Thanks very much, Jeff. Really appreciate that. It was an excellent, excellent presentation. Some great questions going on there as well. Let's see, Jeff, I think you answered most of the questions off the chat. If anyone has a voice question, you can unmute yourself and ask questions. We've got a couple of minutes, and then what we'll do is we'll go to break, and then during the break, we're going to just do some exercises within breakout rooms. So yeah, a couple more minutes if anyone wants to ask Jeff questions, and we'll go to the next activity.
Sure, I will ask a question first. So Jeff, great talk. Thank you very much for the demo. About IAST and SAST, is it necessary to have both SAST and IAST too, or only one is enough?
I think for many applications, IAST is enough, but a little bit depends on your threat model and what you're trying to test. Every application is a beautiful and unique snowflake, so I encourage you to really think about what you want. But IAST has a broad rule set. It covers the kinds of things that static find, the data flow kinds of problems, and the kinds of things that dynamic tools find, because it has access to all the code. all the data flow, all the backend connections, libraries, frameworks, config, and even all the HTTP traffic. So it can do a really good job. And like, I want you to think about your AppSec program holistically. How can you deploy a testing tool that will strategically improve security across your whole application portfolio? And in my experience, SAST is very difficult to do that with. It's not that it doesn't have good uses and that it's not, kind of cool technology. I thought it was interesting when it came out, but I've just seen so many programs where they use SAST for a bunch of years and all they do is they generate a giant backlog, which that doesn't help. So we're trying to change the calculus there. We're trying to empower developers with tools that can let them fix their own stuff. And then the security folks can take a more strategic role. They can be more like coaches and toolsmiths than, in the critical path of applications getting into production. I think that's the right way. And I mean, frankly, I think all of you probably would rather spend your time doing threat modeling, security architecture, and threat intelligence than you would triaging false positives from a static tool. I've done a lot of that and it is zero amount of fun.
Yeah, that's absolutely true. Thank you.
I just wanted to ask on that note, what about, like, I think Dana, you brought that up, the whole shifting left thing, right? Like if you have a static analyzer in the IDE, isn't it valuable that it tells you, hey, this deprecated function, don't use this, like having that early, like just, hey, don't even make that mistake. You're on your IDE, get rid of that MD5, right? Before it even gets to the point where it's compiled and then it gets to IAST, right? Like from a complementary perspective, I think it doesn't add value, or would you say that, it doesn't, that's also going to reduce, cause a lot of false positives?
Well, I always say, look, there's a lot of ways to bake a cake, and I've seen every kind of development organization from one, and actually cake is a good example. Like there's literally like mom and pop shops that bake fancy wedding cakes. And then there's like Tasty Cake Factory, which is completely automated and does everything. And, you have to choose the tools that fit the way that you work. It's not difficult to use IAST right in the developer's environment and give them instant feedback. I showed you some examples of that tonight. So, I don't think
it's an exclusive
necessarily
order.
Always you'd want to use static early. And the fact is, when you use static, there's a cost to using it. It takes a long time to scan sometimes, although IDE scanners are pretty fast. But there's a false alarm cost that you take on. You're going to have to triage those things, and it takes a lot of time. So like, it depends on how the calculus works out for you. But understand that IAST works in real time for complex vulnerabilities, like the most complex data flow problems. IAST identifies them in real time, right in the IDE. No IDE static does that. Static in the IDE only analyzes one file at a time. And I just don't see vulnerabilities in real apps that are fully contained inside a single file. So I challenge the value there.
I think it's one of those things that you use multiple tools to do different jobs. Like I look at SAST as educating developers. We can create rules where as they're working and writing the code, it's immediately telling them when they're following bad patterns that are against our processes. And IAST, can continue to do that. The idea of being able to do it as they're writing the code is where I think the SAST side could come in if someone's managing the rules and actually applying them. One of the things I think IAST gives you that is after the fact is you can run that and instrument that against a product already shipping to see everything that's there at the same time, which is much harder to do from a SaaS perspective unless you're going to recompile and relook at everything. So I think you can do both and it doesn't harm it. I just think that you got to look at how it works for each business.
Yeah, that's a good point. And you can use IAST on, third-party applications that you don't have any source code to. So that's a powerful advantage. We're trying to give you the tech to cover your whole application portfolio really fast. I mean, we've rolled out, one major insurance company, we rolled out to 750 applications in a couple of months by pushing IAST out to all their cloud environments. It can be really fast.
I've got a bit of a weird sort of question, or sort of, I guess, a side question to it. So this is really cool. You've got all this data. How are you preventing your tool from adding more vulnerabilities in? Like all of that data is essentially unchecked user data now passing through your stuff, going to logs. Potentially we have like all of this sort of standard issues around like, magic color codes or things like that being added there, or like all the standard sort of input validation. How are you handling that?
Yeah, so we take the security of our commercial product incredibly seriously. JOT is really a researcher's tool, so it doesn't have any of that. But the product, we put a lot of work into the security story. So there's zero attack surface to the agent itself. Like it doesn't take any data from anything external. It only makes one SSL connection outbound, which is mutually authenticated, strong encrypted outbound connection to our server. And it sends data there. Now the masking is done within the agent. So sensitive data never leaves the application. And all the analysis is done within the application. So you don't have to ship your code around anywhere. All the analysis is done right within the running application in the environments that you already have. So really the risk is, roughly equivalent to adding any other library to your application, right? Except that ours is commercial and supported and tested. And, we put a lot of work into the security story there.
So I'm not going to, cap my logs and suddenly have CRLF be redefined as RM-/.
No. Like I said, all the data goes to the Contrast team server where it's protected, and we've got a sophisticated security story on there. I'll say most of our customers are very large enterprises in finance, insurance, healthcare, airlines, utilities, government, and we get audited multiple times every week. We just got a 1,500 questionnaire from one of our customers. And they're legit questions. They've got a right to ask, how do we protect our stuff? But we're heavily regulated that way.
I bet. And being in the financial sector.
And we use contrast on contrast 24/7, so it's protected that way.
Awesome.
That's actually a much cooler answer.
Do you have any successful production development in microservice, Kubernetes, Docker environment?
Yeah, so contrast runs as part of the application, and it really doesn't matter where the application runs. It can run in a container, in the cloud, in your data center, in a microservice environment, like wherever the application runs, contrast is part of it, and it just runs there.
Okay, thanks.
Which is nice. You can actually take an application using contrast from an internal data center and put it in the cloud, and contrast will just keep working. It'll keep defending the application. It'll keep reporting results into the team server, and nothing changes.
Okay.
Well, great questions. Thanks, Jeff. All right. We'll wrap up this portion of our event for tonight. We'll just take a 5-minute a quick break. Then we'll come back with Bipin's presentation. We're not going to do the breakout rooms today because I think we'll run over time. So we'll do our exercises of breakout rooms next week and promise you some fun and games then. Thanks, everybody. Thanks again, Jeff. That was a great presentation. Have a great evening.
Thanks, y'all.
Thank you.
We can take a few minutes during the break to do some announcements. Dropping the survey link into the chat. I'll let everyone say thanks to Jeff first, but I'll drop the survey link for this particular meetup, and then I'll drop the registration for the Pacific Northwest Conference. That's happening on June 19th, and then I'll also drop the link for the next OWASP chapter meetup as well. That's happening in July.
Was it? Is it July 17th?
15th, I believe.
15th. There we go.
Yeah, 3rd. I think July 1st is is on a Thursday, so July 15th is the 3rd Thursday.
And yeah, join our meetup group to stay on top of all these things. We'll send you lots of notifications about exciting events. Maybe not lots of notifications, reasonable numbers of notifications as necessary. We don't like not lots of stuff. No one likes lots of stuff.
So drop those links. Please do fill up the survey form and definitely register for those events. It's going to be a ton of fun.
Workshops, labs. We're gonna have labs.
Yes, no workshops. We're definitely having labs though.
That's what OWASP wanted us. And this is an official OWASP event, by the way, the June 19 event.
We'll give everyone another 2 minutes and then we'll get Bipin. Bipin, are you good to go? Thumbs up if you're all good.
Yeah, I'm ready. A bit nervous. Of all these legends, yeah.
No need to be nervous. The Vancouver crowd is very welcoming. So definitely thank you for wanting to talk about microservices. All right, let's get going. Okay, our second presentation is about applying security pragmatically to microservices. Bipin is an experienced solutions architect with a wealth of experience in application development across various technologies. He has extensive domain knowledge within the commercial banking, retail, and B2B industries. He is also a certified Mule architect, solution design specialist, and a certified Forge Rock OpenAM expert, as well as a 2FA smart card and PKI subject matter expert. Thank you so much for wanting to speak to us. I'll let you take it from here.
Thank you, John. Thanks for having me here. I mean, it's a great opportunity. You know, it's quite a lot to learn from you, and you know, it's something getting a great opportunity to present. You know what is happening, you know, around. So let me just start sharing screen. Just give me a shout if it is not working for you. I hope it should be okay.
Yep, we can see it.
Okay, perfect. So we'll be discussing about the, you know, monolithic applications. I mean, like, I really want to have these as an interactive session. You know, I'm not going to go too much technical into each component because, you know, each component itself requires a particular dedicated session where, you know, we need to have drill down into each component and start looking into those details. But we'll be typically talking about what is the monolithic application, right? And what are those benefits of monolithic application versus what are those issues that currently, you know, we always face about this monolithic application. Then we'll talk about the microservices and the challenges about it. The security around the microservices, and this is something coming from my own experience, right? What is basically the key challenges that we see around, you know, around this security around the microservices. Then we'll touch base about each different security patterns and you know, applying to those microservices. We'll do a quick demo of Oauth too. I mean, this is something that I pulled in at a very last moment just to have some sort of interaction to show you what are the different tokens and things like that. And then we'll talk about the conclusion, right? Why one single particular pattern is not something useful about the microservices. So what is monolithic application, right? I mean, it's a typical day-to-day operations where you hire genius from, you know, different different organizations, you collect them together, and then you start building an application. So essentially you start building blocks on one after another, right? I mean, you put most of the complex application, you package them together, whether it's a WAR file or ER file, and then you deploy that application, right? Everything is within a single container, right? And that is why we call it a monolithic application. If you see the monolithic architecture, and give me a shout or stop me, you know, in between. I have a very small screen, so I might not be, you know, watching the chat window, but yeah, just interrupt me if I'm talking too fast, or, you know, if you want me to take a pause somewhere, I'll be happy. I just want this more like an interactive session. So monolithic architecture, I mean, fundamentally, we can split that into 3 layers, right? One is the presentation layer, which is something facing to our customers, users, you know, communicating with their different devices. Then we have the application layer, where it collects the data, processes that data, and then the database layer, which is essentially, you know, talking to the database systems, where you have some user information, transactional information, that kind of benefits. Now, the advantage with the monolithic architecture is essentially everything is baked together, right? Like a spaghetti, right? I mean, like someone is, creating those meatballs and sauce and everything, but ultimately at the end of the day, what you get is complete spaghetti in front of you, which you just need to worry about. Okay, I got a good recipe in front of me, right? You don't have to worry about other things, like from the monolithic architecture point of view, where is the security? Because security is something which is, applied onto your application as a framework, right? Maybe you can apply as a security filter within your application, right? And then that security filter will take care of that. Any application or any process flow, the security filter will intercept the request and will make sure that you have this application secure. Is this resource particularly secured? How about the authorization policies around that? And all of those security components are applied natively. I mean, that is one of the advantages. Well, we know the challenges, right? I mean, that is the reason that we want to go with the microservices architecture, because then now we are talking about a single application. If it's a smaller application, is perfectly fine. I mean, and sometimes the advocacy is in such a way that if you have a smaller application, right? I mean, then you don't need to worry about much of these microservices point of view, right? You need to consider about your cost. You need to consider about other aspect, right? I mean, and that is one of the key thing that we talk about in the next slide. But the monolithic architecture, the key challenge for a larger scale organization. So I work with a bank where, as Prashant mentioned, there are 200 plus different applications. Now, those 200 plus different applications wants to publish their code. We have to work periodically, right? I mean, like, okay, so we have this dedicated time window. Yes, we call it agile, or we call it as a agile, waterfall and agile mixing together. But then essentially I have to wait for someone else to complete their coding, complete their testing, and their deployment and everything. And then my code will be tested eventually, maybe 2 months, 3 months down the line. And that's the problem with the monolithic architecture. So company understand that, right? I mean, they realize that for this kind of challenging world, this is not going to help. So they definitely need to run towards the microservices. But often, if you see what mistake application teams that they do is they start pulling out each and individual component from that monolithic application, and then they keep it aside, and they think that I'm going to create a microservices, a mess rather than a mesh. But they put things together and say that I'm going to look into the security later on, right? First, I just want to make sure that I get my application running, and I deploy it into the cloud, and then maybe containerizing that application, so that I'm gonna use that as a microservice architecture point of view, right? Yes, there is of course industry trends, peer pressure that someone else is doing that, my competitors are doing that, so I must be doing it. I'm responsible for my shareholders, or I'm responsible for my the CEO and CTO, so I just want to make that decision as quickly as possible. Other reasons could be most of the time company thinks that can I just go for like buying a new vendor product, right? So build versus buy mentality, where I can say that I'm going to buy a product, like for example, I'm going to do the authentication as a service, and I'm going to use that authentication as a service, right? Cost optimization can be more debatable. Again, as I said, that if you have a smaller application, which is serving a very small scale application, there is really no need for you to create these microservices and deploy that as a whole expensive infrastructure, right? I mean, I don't really see any reason if my, as Jeff mentioned, if you have a cake shop, which is, mom and pop cake shop, which is operating within the lower mainland, I don't need to have different data centers across the different geographies, right? I mean, there is no point creating that kind of infrastructure. There is no point creating, multiple, instances of my application, right? I mean, that is something that we need to really understand. But again, the problem is, or the challenge is that we face every day, me being an architect and my job is to give the consultancy for the application teams. And then the frustration that I always get, that they always keep the security, as a second priority. They say that, I'll come to that. I'll come to the security point, but for me at this moment, I just want to show something to my product owner. I want to show something to my investor that, I have created this service. I can really deploy my application as quickly as possible, and then give the results to the end user. But often it so happens that when they move ahead, then things comes in. Like, for example, you have your security testing comes in, you have your audit comes in between, and they realize that, oh, you know what, we need to apply the security now. But the challenge is then they don't have any pattern. So often it happens that they think about one pattern, look around, they say that, yeah, there is one pattern available, let's apply that particular pattern. And that's the key challenge that we see, during any microservices architecture or design, or even in the development phase. So if we basically define these microservices, I mean, like you containerize this application and you ship them, you put them into Kubernetes, or you run that as a Spring Boot application, even on a VM, or sometimes, like a different vendor products like Mule and everywhere, right? I mean, you put that application, and then you put one single security pattern, but then you forget about what kind of a microservice, what kind of API that you are exposing. It's kind of a promotional offer. For example, if your company, or if you're a bank or insurance company is offering a promotional offers, I mean, there is no need to have a rigid authentication process or authorization process, right? Anybody as a guest can get into the system and can look into those promotional offers. Similarly, like a rate inquiry. Now this can go a little bit dynamic. So for example, you being as a tier 1 customer, you'll probably get a better rate. So yes, you can have your authentication and authorization. So then you can authenticate and authorize as a tier 1 customer and say that, if I'm a tier 1 customer, I'm going to get a better rate, maybe on a foreign exchange rate. I'm going to get a better promotional offers on the product, right? But then it goes a little bit more further on like a user management, right? So you have kind of a system administrator. In a commercial banking, we have millions of users, and we talk about large scale organizations or companies where system administrators are maintaining, hundreds of different users under that organization. So their user management requires more stronger authentication, more stronger authorization. Then it goes more, complications like account management, right? Like I want to retrieve my account balance. I want to, do some transactional services like a transfer my account balance. And if I have all these as a microservices, and if I'm saying that now I'm going to apply a single security pattern for these microservices, then there are a lot of challenges, and which we have seen on a day-to-day basis, where you cannot just simply apply one pattern and say that oh, I have applied the security and my job is done from the security point of view. That's not the good way of doing. So they often come like, what are those API security patterns that we have, right? I mean, like most of you must be already aware of that, but just to iterate here is basically, yeah, you can do the MTLS, right? It's a mutual trust between your application and a server application, or you can use the API keys, very simple as it is. You can use client credentials, like a client ID secret or AD credentials. Now, client ID and secret I put together along with the AD credentials. I mean, fundamentally, they work together, just that the AD credentials will have a little bit of authorization touch as well. Then you can go with the SAML token or JSON token. JOT tokens are essentially very popular, where you can bake certain information into that, and then you can give that token to your application or API, and API can validate the signature, verify certain details, and serve that API. Or you can do the Auth 2 tokens as well. And that's the whole reason. I mean, when we look into each individual pattern, I'm just checking if there are any questions or Okay, so let's move on. So mutual TLS is pretty standard. I mean, it's there for a long time. It's a very typical example. Alice and Bob, they share their secret with each other, and every time when they communicate with each other, they pass their information to each other. So then Bob can understand that, hey, you know what, the request is coming from Alice. So then I'm going to give the response back to Alice, and Alice understand that the response which I'm getting is indeed coming from Bob, right? I mean, it's definitely a protective measure against man in the middle. Mutual TLS is a simple way of implementation. When I say simple way, not from the technological point of view, but the easiest way where you can say that, you know what, I can implement the MTLS between my consumer application and my service API. So then, both can talk to each other. But what are the key design considerations that you need to have, right? Is that if your API is a very public API. For example, if you're giving, like a weather forecasting or current, foreign exchange rate, right? What if your API or your consumers are not a part of the same MTLS ecosystem? I mean, that is what one of the key challenges, right? So if it is not a part of that ecosystem, then how you can have that mutual trust between your application and the consumer application, right? There are various different APIs which can get they can send the request, get the data back, but they're not a part of that same ecosystem, right? So that's something you need to consider about, about that. Now, some of your own microservices might not be necessarily MTLS enabled. Right? What are those? I mean, definitely, it's a better practice, but what if you don't have those, MTLS enable the microservices? You can use service mesh, such as, console or Istio, where, you can have your application, deployed within that, mesh. But then again, same question, what if my application is not a part of the same ecosystem, right? I mean, then when I design my microservice, I need to make sure that what kind of API that I'm exposing, does it require any extra layer of authorization, right? I mean, this is where you need to think about it from the application point of view. Then again, as we say that, yes, we can go one step further and say that, what, if I just want to make sure that if I'm going to serve a simple API for my consumer application, they are not a part of the same ecosystem, I can give them the API keys. Of course, you can give them the API key, like client ID and client ID credentials, like client ID and secret. You can encrypt, and you can do whatever, a fancy mechanism to share that information with your consumer application. So they can have the encrypted key, like a client API key or client ID and secret, they can be encrypted. But it's always good to have, apply onto those non-transactional services, right? For example, we have seen often that you have the client ID and secret, even though those are encrypted. Sometimes, people put them as a standard, application statements, right? They put it into the logs get pumped into, other systems. Other system can read that information and so on and so forth, right? So that is where it becomes really challenging, that, what kind of information you are trying to protect, what kind of API access that you're going to give, right? It is simple, for an instance, get active users versus the get users data, right? There is a lot goes in between these two different APIs, right? From the system administrator perspective. AD-based authentication is good. Now, the Active Directory can give you one additional benefit, is that you can define your tree and you can have some additional level of authorization on top of that. But the challenge is that with AD, and that I personally feel sometimes that you have a dependency on that Active Directory as an infrastructure. So then what if someone is maintaining a different team entirely maintaining that AD credentials? What if someone come and change the tree altogether, right? I mean, if they don't understand, they change the entire tree, then essentially your application is now vulnerable, or your application is now application can really go down because you cannot have that authentication mechanism established. So what are those service level agreement that you should be doing with the AD, right, the Active Directory, or what are these key performance indicator that you need to do? For example, if you have a high volume API, then how you are gonna basically resolve that issue when you have a peak time and your application is always going back to Active Directory, doing the validation, checking some, the authorization policies and coming back, right? So these are the key things that you need to consider in your application as well.
I have a question here.
Sure.
How does AD authentication work in this context? Is the username password passed to API, or is the corpus ticket?
Create the kind of a service account for an instance, and then you can store those service accounts into Active Directory, and you can pass these service accounts, and you can, of course, you can have a password as well, and then you can pass that. Now, most of the time, AD authentication can work in such a way that you have your consumer application running on site of your vendor system, right? And then you have a service provider application running somewhere else. Let's say your service provider application or your API is running in cloud, which is completely a different system. There is no need for you to establish a new authentication service altogether. What happens is basically your application, that is your consumer application or your customer application, they might have their own Active Directory based authentication or authorization, right? Their internal SSO application. So they say that, you know what, I have my authentication and authorization within my organization, I'm going to use that. So then you can use those Kerberos token or, like your SSO tokens within your application. You authenticate within your application and provide that token back to your service API, and service API can validate that token.
I see. Thank you.
Yeah, no worries. Then it goes to a SAML token and JWT token. Now SAML, we know that, right? It's a good, but the only challenge, and I usually like the JWT token. The reason behind the JWT is very lightweight. The very first thing, whereas the generation process of a SAML token, where you have SOAP and all those things, can be really challenging. The schema itself is very complicated sometimes. I'm not here to argue about SAML versus JWT, but I'm giving you some personal opinion based on the lightweight application. But both of them serves the same purpose at the end, right? I mean, the beauty about these tokens that you can bake necessary needed information into both of these tokens. Like, for example, you need to generate a token on your application on a consumer side, and then let's say you have your own identity provider, or you are using another identity provider, and then you do your authentication, you do your authorization within that application, and say that, I'm going to create this token now. That token contains user information, like your customer information, your basic authorization policies, that what this particular user can access and cannot access, that kind of information, and you pass that token to your resource provider. The resource provider only needs a public key from the IDP provider, whoever is essentially generating that token or assigning that token, the public key of that signer, and they can verify the signature, get the data out of that, and then then serve the API according to the request. But definitely you need to have some key consideration, because since then your application will be sending the token over internet, you might need to think about adding some extra layer of encryption on top of that, depending upon what information you're trying to bake into that. Now for an instance, let's say, for example, you have your consumer application. Let's say you have application A, B, C, D, E, and these are 4 different entities or 4 different consumers. Then you might have to give them a single IDP solution, or you need to deploy multiple IDP solution. All of those things that you need to consider, like what is the IDP's SLA, right? What is the service level agreement that you can have with these consumers, right? One consumer application might require 24/7 running. It's kind of a tier 1 service where where the service cannot go down, right? It's running across the different geographies. How you can protect your identity provider, right? Whereas the other service is a pretty smaller service, right? I mean, it doesn't need to be a tier 0 service, right? So all of those things that you need to consider. So when your service is running 24/7, what are these, TPS, right? Transactions per seconds. What is the load that you're going to put into your application? All of those things that you need to, consider. Of course, the key rotation is a key thing, and that is often become as a challenge for most of the cases. I mean, definitely you can use, like a Vault or KMS, Google KMS, for your encryption mechanism. But all of those things that you need to consider when you actually give JOT token as a solution. Now, again, if you see these number of different patterns, I mean, you need to think about what exactly you're trying to protect, right? I mean, who are your consumer base? How many frequent calls they are going to make to my application, right? I mean, if you have an application which or you have an API where your API is, is not gonna consuming a lot of transactional information but requires a high security, then of course, the JWT token is probably a right choice, because you have these strict authentication and authorization policies implemented onto your API. Versus, if you have an application such as we have an application for an instance which only shows you a dashboard, but the dashboard only shows you a metadata, right? Like, for example, how many alerts got generated in your application, how many total transactions happened in a day, right? It doesn't require any detail. Of course, if I click on that particular like a notification, then it goes and give me the details about that notification. Like for example, from that transaction data point of view, my debitors account information and creditors account information, all of these things which is important. I mean, that is where you probably need to think about where I need more authentication and authorization. See, one thing that I work with the bank, and I work with very different regulators. I work with South Korea, Egypt, and different regulators, and every regulator, they have a different needs, different requirements. Their security need is different. So you cannot have one one size fit for everyone. I mean, definitely you can work with different regulators, take a good component or a mean out of all of those things and say that, what, I'm going to apply a standard security pattern. And I work with Farshad a lot. I mean, we faced a lot of regulators back in those days, and that is the key challenge that we always have.
So many regulators.
So, and that is where the security pattern comes. I mean, like, I have seen, regulators get really frustrated when we say that, oh, okay, so you have this API, what is the security? Oh, this is the security pattern that we are applying. And what about that? So they really sometimes, feel frustrated and say that, what, if you have one API and if you have one security pattern, what if that security pattern is now vulnerable, right? Then essentially all of your API, no matter what kind of API that you have, all of those APIs are essentially then exposed to the external world, right? Whether it's a public API or private API. Now, definitely you can have your network like a zero trust model, and then you can have your network perimeter secured in this way. But yes, I mean, fundamentally, the issue that we are facing in current world, in today's world, yes, external threats are of course there, and there will be always the external threats. But sometimes the key challenge is the internal threats. What if you have any rogue employee, which is basically trying to do something, which that employee is not supposed to do, right? I mean, all of those things that you need to consider while applying that security pattern. I'm going to change.
I do have a question. One of the things that I've encountered with APIs is you really have to pick like what grant type you're going to use. I did drop a couple of good references in the chat just to help people out. There's a flow chart that you can go through to know whether your client app, like a backend service or a single page app or a mobile app, can be trusted to keep your secrets. And that goes, I think you had on the slide prior to this, like client credentials grant type. Most people kind of default to that auth code grant type, but you do have to like think about that when you apply OAuth.
Sorry, I didn't get your question clearly. My apology. Probably it's my network is not stable at the moment. But you mentioned that you have an API, you have some sort of a dashboard, and then most of the time that your consumer applications are using the API key approach. Is that the correct understanding?
When you're applying OAuth, you have to think about what type of
Flow
grant type you're using, the flow, right?
Yeah.
Yeah.
If I can maybe translate. Yeah, the question is, because absolutely that's a really, really good point, right? Because if you're using Auth 2, there's a whole bunch of different flows, and oftentimes developers use the incorrect flow. So the client credentials grant flow would be the right one to use if you're doing this type of in this scenario.
Yeah. No, definitely. I mean, that's a great question. I mean, that is the reason that I put the OIDC and Auth 2 at the last. I mean, I initially thought that maybe jumping between these two things, but then I realized that it's going to be really confusing. Auth 2 is a really good thing. I mean, like talking particularly from the bank perspective. I mean, the demo that I'll be giving you on something else, but from the banking perspective, traditionally, the way that we saw that, I have my banking application, whether it's a desktop application or mobile application, I can essentially use my mobile application, like, my bank specific application, logging into the system, get my balance and, make some transactions, and I'm happy with that. But the banking is changing now, right? I mean, there are so many social media apps, like in China, we have a WeChat. I think in India they are talking about WhatsApp as well, doing some transactional business as well, and then some regulatory requirements such as in UK, open banking, or in Europe there is a PSD2, right, Payment Service Directive transactions, where you can have your own different. Let's say, for example, from the Canada perspective, you have your RBC Bank, mobile app, and you have an account with RBC and TD. Technically, they are saying that you should be able to check your transaction within that particular single application, right? I mean, these kind of things which can make it really challenging, and that is where Auth 2 comes in place, right? How you can basically define that as a pattern, right? So take a simple example, right? Like I have my cool app, right? I mean, that cool app is essentially taking a lot of data from different applications, different service provider. Like it can show you a dashboard showing your number of emails. It can show you your what are the calendar entries that you have, and then it can show you the health data as well. I mean, like as simple as like your mail alerts, like the notification that you in Gmail you have these emails, versus the more complicated like the health data, right? So if I just simply say that, I know the endpoints, I'm just going to call those endpoints, and I'm just going to make a call to those endpoints, and yeah, I mean, I can create a service account, right, on Google, and then I say that, I'm just going to pass this information to Google and say that, I need this information, right? Because my user trusts me. Can you just give me that information? The consumer application will simply say that, I do not trust you. Right? Forget about the user. You might be saying that you have a legitimate user which might have, account with my Gmail or my calendar or, like my health and whatnot, right? But I don't trust you. You as an application, I don't trust you. So that's not going to help, right? So he said, okay, so then what is the process, right? So then the process is essentially you register your app, then you complete your consent journey, saying that, that's an agreement between your application and the service provider, right? So that means you say that, I'm just going to make a registration with you. So I'm going to ask only for this particular data, for all the authenticated users, then you're going to provide that much information. And then it says, yeah, that's perfectly fine. So then you register your app with a service provider. Service provider gives you the client credentials, then you use those client credentials to communicate with the service provider. But the consent journey, the consent management, everything happens between user and then the service provider. So if you see from the flow perspective, so let's say Alice wants to get some information, like she wants to check her total number of steps that she walked, today. How she's going to do that? She said, hey, she's going to go on a cool app, say that, show me my dashboard, how many steps that I have taken today, right? So cool app will say that, what, for this you need to do the authentication, right? So then it goes to the authentication server. Authentication server will generate the authentication token and will send it back to the cool app. The cool app will then take that authentication token and goes to the authorization server. Now, particularly in this diagram, I have put authentication server and authorization server as one entity, but not necessarily. So then you need to have that, establishment between authentication server and authorization server. The authentication token that is generated by your IDP must be again revalidated by authorization. The authorization server must send that token back to authentication server. So then authentication server can validate that token. So then authorization server can say that, what? Okay, so I know cool app. I understand that this user, Alice, has authenticated successfully. Now she wants to find out her total number of steps that she has taken today. So then the authorization server, this is the grant agreement between the cool app and the authorization server, will first validate that, is this cool app is asking something additional to that, the consent management? If not, then it will simply say that, what, you need to give the consent, right, Alice? Because do you give the consent to cool app to access your, access the data on behalf of you? And you give that consent, and we'll show you into demo quickly. And then it will say that, yeah, user gives the consent, and then the authorization server, service server, validates that and give that information back to the resource server, and resource servers pull out that information and sends the information back to Alice. So this is the whole consent management journey. Any question in this flow? Okay. So we'll do a quick demo. So, the good thing is basically there is the Oauth 2 playground, which is developed by Google. And then, the one of the things is, like, you can see, for an instance, not necessarily Google. There are different APIs. You can establish your own Oauth 2 module, like the way that you are, for example, from the open banking perspective, we as a bank, that we have a different, authentication and authorization model for that. But this is a very good playground to start with, right? So what I'm going to do here, I'm going to just extract the fitness API. So I'm going to say that, I just want to get these, fitness activity, right? I'm just going to read the fitness activity. Now, if you see, I have this URL available. Can I just make invocation of that URL directly from within my application? It looks like like a REST endpoint. I should go into my Java application and make that request. Let me see if there are any questions. Oh, not seeing the demo screen. Sorry. Let me see what's going on here. Are you able to see the whole screen now, or you see the Google Chrome window?
Yep.
Okay, perfect. Sounds good. Sorry about that. So this is the endpoint which I was saying, right? So you have this endpoint, like it looks like a REST endpoint, right? Can I just go to my Postman application, right? And can I just send that request? I just want to get that information. Can I just get that information, right? But no, this is where the whole Oauth 2 comes in place, that you need to make that agreement, right? You cannot just simply make a request from your application to the service provider and say that, I just give me that information. That's not how it works. So you say that, yes, this authorize API. Now remember one thing here, the consumer application is essentially your this Auth 2, excuse me, this Auth 2 playground is your consumer application, right? And this is the application now registered with Google, which says that, yeah, I mean, I'm going to give this Auth 2 playground as a registered application. So whoever is coming with authentication, and I give the authorization, as long as I give the authorization to that particular user, I mean, as long as the user gives the authorization to access the data, I'm good. So if you notice here, what is happening, the moment I select the API here, if I go back here into the fitness API, I say that I want to see the read activity, please authorize this API, right? So this application now trying to access the information, it says that, oh, okay, so you want to log in. So I'm going to say, yeah, I'm going to log in into the system. And I logged into the system now. And the authentication part is now done here. So if you go back, your authentication is done, the authentication token is now generated. Now the authorization grant comes in play. So the authorization grant is says that you already gave playground access to use Google Fit to see and store your physical activity data. I mean, this is the consent that now me as a user giving it to my service provider, telling that, yes, my Google Auth 2 playground as my app, I'm going to give my consent to access the data on behalf of me. And I say, yeah, allow. And yes, it says that, okay, now we're talking, now we got the authorization code. Now what I'm going to do, basically, I'm going to generate the refresh token and access token. And I'll come back to this point. So the authorization code is done. Now I have given the authorization. Then I create the refresh token and I can give you the access token. But remember one thing, the access token here is a bearer token. Now I can simply take this access token, go back to my Postman, and I can run it. Right? So when I run this entire thing, so if you see that the total number of steps, and then there's a lot of goes into body and all of those things, I mean, which is application specific message specifications, right? So what all you need to do is basically I need to start my time in my start time, end time, and then the data source ID and all this. This is application specific. There is a lot of dance goes behind the scene, but what ultimately I get is the value. So that means total close to 7,000 steps, Alice walked. This is just storage data. Total number of steps, like a 7,000 steps, right? So that information. Now, access token is a bearer token, right? So the bearer token means that anybody can have access to this particular bearer token, can essentially retrieve the data as the way you see, right? So look at this point of view. Auth 2 playground is an application. My Postman is another application. They have nothing to do with each other, right? I get a hold of this access token. I can pass that access token, and then now data can be easily retrieved. So what usually is a standard practice, you keep your access token, the validity of access token should be very, very minimal. The way the applications start communicating with each other is mainly with the refresh token. So the refresh token is the one that should be used against the communication through the service provider. There are multiple benefits that you can do. So for instance, you can create a refresh token for longer, as long as you have your security team, or you as a security consultant can agree on that. For an instance, in some of the cases, the refresh token can live for 90 days. What does that mean? That for those 90 days, that user don't have to do the authentication or authorization every single time. So as long as they do the authentication or authorization, I'm absolutely fine. So that's the way it works. So that's the access token and refresh token. Then I'm going to just quickly clear my cache here. And I'm going to show you from the, actually, I don't have the consent on my application because the application is still running. But let's say, for example, I have my imfitonline.com, right, where I want to get the dashboard here, right? So I click on my dashboard. It says that, I'm going to get the Google Fit activity data here. I'm going to use the same. So this is the authentication part. Since I have given the authorization, and since this application is essentially registered into that, it can go and get the data. Now, this is again just a sample dashboard. It might be getting some older data and all of this thing, but this is the information which can give back from the application. It gives a lot of information. I mean, it gives you whatever the information that you have asked Google to give, and that's the agreement that your consumer application makes with the authorization server. That what information that I can access on behalf of this user, and what is the concern. Now, definitely there is a lot of things goes in there. Like, for example, if you're accessing the health data, then there are a lot of other regulatory documentation that you need to work with Google. But that's a different a business dynamics, I should say. Yeah, I mean, this is what it is. I mean, from the OAuth 2 perspective, and OAuth 2 is really good. Again, it's baked into the security, but again, depending upon what kind of API that you're exposing at the end. Any questions so far? Okay, I mean, yeah, I mean, yeah, this is very cool stuff. I'm like OAuth 2 playground or OAuth 2. You can also spin up a quick cloud environment. You can run with that. It's a great way of understanding how the token flows works. What is the validity of the token? How and how you can exchange this token with the different tokens like refresh token, access token. Okay. Okay, thank you.
So Bipin, would you mind sharing the link for that playground?
Yeah, sure. Yeah, I'll do that.
Awesome. I'm actually curious to go play around with it myself. When it comes to OpenID connector and OAuth, we work with developers day in, day out, and that seems to be the main problem point. We find that I'd say a good majority, close to maybe 80% of people building these flows don't really do them properly. And so this is a really good thing for developers to be aware of these different flows, and this playground is a really good tool for that. Thanks for sharing.
Yeah.
So any other questions for Bipin? Steven, you're saying OIDC at work is great. Yeah, OIDC is great. And just FYI as well for everybody. So OpenID Connect is just OAuth 2 with a few extensions, right? Like the original OAuth 2 only supported reference tokens. It didn't support JWT tokens. They extended OAuth 2. Yeah. And the original, and OAuth by definition is for authorization only, right? So a lot of people confuse that. And I asked them, hey, how are you doing authentication? They're saying we're using OAuth. Well, that's not really authentication. It's an authorization protocol, et cetera, et cetera. OIDC was like, hey, we need to do authentication. So they basically took OAuth and added the authentication pieces to it. So you've got the ID token and a few other things. But if you look at OIDC flows, they're pretty much OAuth 2 flows. And as someone posted here on the chat as well, use OAuth very carefully. One of the original people that worked on the project quit because he was just like, it's really insecure, but insecure in the sense that the protocol itself doesn't really provide a lot of foundations for security. So you really have to know what you're doing and follow the right flows and put lots of things around it. There's lots of common mistakes where people use access or refresh tokens, or they don't understand what access refresh tokens are for. They'll use the access token that lasts forever. It's really widely scoped. Lots and lots of problems can occur by not knowing what you're doing when using OAuth. Yeah.
Well, it's always like a simplicity comes with a greater risk, right? I mean, yes, OAuth 2 opens a lot of opportunities, and I'm sorry, I mean, I should have said that like OAuth 2 is definitely a subset of OIDC. You use OIDC as an authenticator, and then OAuth is as in your authorization framework. They always go hand in hand. I mean, there is nothing that you can have a differentiation between these two applications and say that, or the protocols and say that, can I use just OIDC, but then for what, right? I mean, what are you trying to gain by doing that authentication. So for instance, you just have some sort of a social authentication on your application, and then you establish your own session and you have own, authorization policies and everything, then yes, you essentially go with that OIDC flow.
Awesome. All right, well, if there are no other questions or comments, Steven, are there any last minute announcements that we want to make, or we basically have?
I've dumped the information again. Please do the survey. We always love to hear feedback from you, and we can always make the chapter better. Pacific Northwest Conference, it's happening June 19th. Registration link is there. Please, I think you'll be very excited with the content that's going to be there. And then, Roberto mentioned, I hear the website is live for Pacific Northwest.
Yes.
Roberto, if you know the URL, it would be a great time to post it in here as well.
And thanks to Roberto. Roberto represents the OWASP Victoria chapter, and they're doing a great job growing the chapter there as well. Thanks for posting that link, Roberto. If you want to put a plug for your chapter's upcoming events, let the audience know as well. You can Google the OWASP Victoria chapter as well. They have the website, and they post what's coming up there. We're excited to be partnering with them as well as the Portland chapter to bring you this conference.
Perfect.
Awesome. Well, then again, once again, Jeff, thank you very much for the presentation tonight, and Bipin, you as well. And I think if we had a competition for winning icons, Harisa Akimian would win one. Hers is pretty funny there. But yeah, thanks everyone for attending. Thanks for our volunteer board for making these things happen. We put a lot of work into them, and we appreciate you attending and enjoying them. And until next time, have a great evening.
Thank you so much. Yeah.
Thanks, everybody.
Thank you.
Bye-bye.
Stay safe.
Thank you. Have a great night.